Assalamualaikum class. How are you all doing? I hope you guys will be taking care of yourselves from the present situation. And I also hope that you have gone through the last lecture of red blood cells very well. I know that you guys have learned that as well. So let's move towards the today's lecture, which is about the erythropoiesis. I just want whenever you are listening to these lectures, the book should be in front of you people, and you guys need to underline, highlight all these points which we are discussing in the class, in this online class. So let's start. Erythropoiesis. Erythropoiesis is the process of origin, development, and maturation of erythrocytes. So erythrocytes are the red blood cells specifically, and erythropoiesis is the process of the origin, development, and maturation of red blood cells. Hemopoiesis, on the other hand, or hematopoiesis, is the process of origin, development, and maturation of all the blood cells. So you see, when you're talking about all the blood cells, you're going to say hemopoiesis. But when you're talking about erythrocytes, red blood cells, you're going to say erythropoiesis. So what are the sites of erythropoiesis? Let's first talk about the fetal life. In fetal life, there are three stages: the mesoplastic stage, the hepatic stage, and the myeloid stage. In the mesoplastic stage, this is the stage of the first 2 months of the intrauterine life. So yes, in mesoplastic stage, we are discussing about the first 2 months of the intrauterine life, where the RBCs are produced from the mesenchymal of the yolk sac. Then is the hepatic stage, which starts from the third month of the intrauterine life. The liver is the main organ that produces RBCs. Spleen and lymphoid organs are also involved in erythropoiesis. Then comes the myeloid stage, the third stage, which starts during the last 3 months of intrauterine life. The RBCs are produced from the red bone marrow and liver. So this myeloid stage is the third stage. Let's revise the three stages in the fetal life: mesoblastic stage, the hepatic stage, and the myeloid stage. Mesoblastic stage is for the first 2 months. Hepatic stage is for the third month, and myeloid stage is for the last 3 months. Then what about the site of erythropoiesis in newborn babies and the children and adults? In newborn babies, growing children, and adults, RBCs are produced only from the red bone marrow. So only the red bone marrow. Up to the age of 20 years, RBCs are produced from the red bone marrow of all bones, whether they are the long bones or they are the flat bones. The RBCs are going to be produced in all of these bones. But right after the age of 20 years, these RBCs are produced from the membranous bones like the vertebra, the sternum, ribs, scapula, iliac bones, and the skull bones, and from the ends of the long bones. So after 20 years of age, the shaft of the long bones becomes yellow bone marrow because of the fat deposition and loses the erythropoietic function. So you see, after 20 years of age, why the long bones are not involved, because they become the yellow bones. They do not remain red bone, but they become the yellow bone because of the fat deposition, and so how they loses their erythropoietic function. All right. In adults, liver and spleen may produce the blood cells if the bone marrow is destroyed or fibrosed. Collectively, bone marrow is almost equal to liver in size and weight. It is also as active as liver. Comparatively, 75% of the bone marrow is involved in the production of leukocytes, and only 25% is involved in the production of erythrocytes. But that is because of the amount of leukocytes is very less in number as compared to the amount of erythrocytes. And the lifespan of erythrocytes is also a lot greater than the lifespan of leukocytes, which is only about from a day to a few days. So these were the initials of erythropoiesis. We have learned about the meaning of the word erythropoiesis, hemopoiesis. Then We have learned about the site of erythropoiesis in the fetal life, in the newborn babies, then in the children and in adults. Now let's move towards the very important part, which is the process of erythropoiesis. The process of erythropoiesis starts from the stem cells. First, you need to know what are the stem cells. Stem cells are very important. Stem cells are the primary cells. They are capable of self-renewal and differentiating into specialized cells. You see all of the cells of your body. First, they were stem cells. The stem cells are not differentiated. They are just cells, and they will be given a command in their life, and according to that command they will become RBC. They can become a neuron, they can become a cell of the liver, they can become a cell of your skin. So you see, stem cells are just the primary cells which are capable of becoming any of the cells of our body on the action of the brain. So hemopoietic stem cells are the primitive cells in bone marrow which gives rise to the blood cells. Hemopoietic stem cells in the bone marrow are called uncommitted pluripotent stem cells. To understand the process of erythropoiesis, you need to learn this flowchart very well. I'm going to make you understand this concept with this flowchart. Just look at here. It starts from the uncommitted pluripotent hemopoietic stem cells. These stem cells in the bone marrow are known as uncommitted because at the present moment they have uh, no concern, or they have been not given any of the command to become the specific type of the cell. So they are known as uncommitted. Right after the command has been given to them to become a red blood cell, to become a platelet, or to become a white blood cell, then they are known as committed pluripotent hemopoietic stem cells. Then committed pluripotent hemopoietic stem cells can be of further two types: the lymphoid stem cell and the colony forming blastocyte. The lymphoid stem cell can turn into leukocytes, the white blood cells. Then the colony forming blastocyte will turn into the colony forming unit E, RBC. Then this colony forming unit GM will turn into granulocytes and agranulocytes. The granulocytes are neutrophils, basophils, eosinophils, and this M is monocyte. And then there is this colony forming unit M, megakaryocyte, which will turn into platelets. So you see, this whole story, this whole flowchart is telling you a story from the bone marrow. When the stem cells are uncommitted, then they become committed upon the action of whatever they have, whatever they are getting the action from the brain, and they are getting the command of becoming the lymphoid stem cells or colony forming blastocytes. Either of them, when they have become the lymphoid stem cell or the colony forming blastocyte, the lymphoid will turn into the leukocyte, whereas the colony forming unit E will become RBC. Colony forming unit GM will become neutrophil, basophil, eosinophil. M is for monocyte, and colony forming unit M is megakaryocyte, which will turn into platelet. So I hope so you understand. By now you are going have a good understanding of what is the process of erythropoiesis, what is the initial process of erythropoiesis, and how the stem cells are being converted into specific cells from being non-specified. So this is the this is just the generalized description of what we have seen in the flowchart. Now we are going to move towards the changes that occurs during erythropoiesis. Specifically, what are the changes, what kind of cell a stem cell is, and then how it changes to become a red blood cell. For that, we need to know these stages of erythropoiesis. There are 6 important stages of our erythropoiesis, which are pro-erythroblast, early normoblast, intermediate normoblast, late normoblast, reticulocyte, and mature erythrocyte. For your understanding, I've made a short note and I want all of you to make these notes as well. I just hope you can see it from this from my camera. I have made this flow chart um, in which there are different stages of the erythropoiesis, and then at the sides I have written the important points of all these stages. So let's see what happens in the proerythroblast, which is also known as the megalloblast. It is a stem cell which is when given the command to become an erythrocyte, first takes the shape of the proerythroblast. The proerythroblast is very large in size. It has diameter of 20 micron meters. Then the nucleus is very large. Yes, right now here the nucleus is present. It also has a reticular network. It does not contain the hemoglobin. The cytoplasmic plasm is basophilic. Then the proerythroblast multiplies several times to become the early normoblast. So let's revise the proerythroblast. Proerythroblast is a large cell. It has a large size. There is a large nucleus present in it. There is no hemoglobin, and the cytoplasm of the proerythroblast is basophilic. Now, what is early normoblast? In early normoblast, you see the cell becomes a little smaller than proerythroblast with a diameter of about 15 micron meters. So the proerythroblast was 20 and this is now 15. Here, what happens is in nucleus, the nucleoli starts disappearing. The nucleus does not disappear, but the nucleoli starts disappearing. So the first important point you should remember then is that the nucleoli starts disappearing in which stage? In the stage of early normoblast. Then comes the condensation of the chromatin network. Chromatin network is the part where the DNA is going to be formed. So we do not have nucleus and we do not need DNA in the RBC. So there is going to be the condensation of the chromatin network. The condensed network becomes dense. The cytoplasm is basophilic in nature. That's why the cell here is known as basophilic erythroblast. Yes. So if I'm going to ask you which of the stage is known as erythroblastic, basophilic erythroblast, so you are going to tell me it is? Yes, early normoblast. Intermediate normoblast. The cell becomes more smaller, like the diameter is 10 to 12 micron meters. The nucleus is still present. The chromatin network shows the further condensation and the hemoglobin starts appearing. The cytoplasm is already basophilic, so it's again basophilic. So the hemoglobin starts appearing. This is the important point of this stage, that in intermediate normoblast, the hemoglobin starts appearing. The intermediate normoblast is acidic and basic as well. That's why it is known as polychromatic erythroblast. Then comes the late normoblast. The normoblast size of the late normoblast is 8 to 10 micron meters. So you see it has further condensed from the size of 10 to 12 to 8 to 10 micron meters. Now the nucleus starts becoming very small in size, and the chromatin network is just like the ink spots in the nucleus, or ink spot nucleus. Then the hemoglobin starts increasing in quantity. The cytoplasm is still acidophilic. That's why it is known as orthochromic erythroblast. Now, one important thing to be noted here, that the cytoplasm only becomes acidophilic here. That's why this type of the stage is known as orthochromic erythroblast. All right. In late normoblast, another important thing happens, which is the nucleus disintegration and disappearance. This point is known as process is known as pycnosis. So, if I'm going to ask you, pycnosis occurs in the late normoblast. The fifth stage is the reticulocyte. Why it is known as reticulocyte? It is known as reticulocyte because the chromatin network is only like a reticular network. Only the remains of the organelles and the chromatin network have been left. The all of this waste is known as reticular networks. So this stage is known as reticulocyte. So we call the stage as an immature RBC as well. Not the mature one, but the immature one. The cytoplasm here is basophilic because of the disintegration of all the organelles. The cytoplasm again becomes the basophilic. Then comes finally the mature erythrocyte, the mature RBC, the RBC you want in your blood to be circulated and to perform the normal functions. Here in mature erythrocyte, what happens that the reticular network disappears, the RBC becomes mature, the hemoglobin is completely present and the nucleus is completely absent. That is what a mature RBC is. And another important thing is that you need to remember that whole process takes 7 days. The process from the stage of proerythroblast to the stage of mature erythrocyte, it takes 7 days to be completed. And furthermore, from erythroblast to reticulocyte, it takes 5 days. And from reticulocyte to become a mature erythrocyte, it takes 2 days. So this is the process of erythropoiesis. Then we have a few factors which are necessary for the erythropoiesis. These are the general factors, the maturation factors, and factors necessary for the hemoglobin formation. So the general factors which are important for the formation of erythropoiesis are the erythropoietin, which is a hormone, thyroxine, which is also a hormone, hemopoietic growth factors, and vitamins. So you only need to learn their names, not the complete description which is given below it. Then comes the maturation factors. Which factors are important for RBC to become mature to pass the stage of reticulocyte to matured RBC? That is vitamin B12, known as cyanocobalamin. Also, it is intrinsic factor of Kessel and folic acid. So these are the factors. Again, you only need to learn their names. Then comes the factors necessary for hemoglobin formation. First class proteins and amino acids, iron, copper, cobalt, and nickel, and vitamins. These all are the necessary factors important for the hemoglobin formation. So that was all about the chapter, but before completing the lecture, we need to revise it. Let's revise what important things we have studied so far. We have studied the definition, the meaning of erythropoiesis, the meaning and of hemopoiesis, the difference between erythropoiesis and hemopoiesis, then the site of erythropoiesis in fetal life, which further is having three stages: mesoblastic stage, hepatic stage, and the myeloid stage. Then in newborn babies and children and adults, what happens? We have divided it into two parts. That the erythropoiesis occurs at the age of 20 years in all the bones, whether they are long bones or they are the flat bones. And after the age of 20 years, the process of erythropoiesis only occurs in the membranous bones. Liver and spleen are also helping us in the process of erythropoiesis. Then we move towards the process of erythropoiesis, for which first we learned about the significance, about the understanding of what are the stem cells. You guys really need to learn this flowchart: uncommitted pluripotent hemopoietic stem cells converting into committed pluripotent hemopoietic stem cells, and further onwards. Then the basic stages of erythropoiesis. All right, I am going to ask you a few questions, which by the end of the lecture you need to answer me without looking at the book. So, where is the process of pyknosis? In which stage the process of pyknosis occurs? In late normoblast, which is the stage in which hemoglobin starts appearing. I repeat, what is the stage in which hemoglobin starts appearing? Yes, this is the intermediate normoblast. Um, which stage of erythropoiesis is known as polychromatic erythroblast? Yes, this one is also intermediate normoblast. The other question is which stage is known as basophilic erythroblast? Yes, basophilic erythroblast happens in the early normoblast. Then, how many days it takes to complete the whole process of erythropoiesis? Yes, these are 7 days. So these were some important questions from what we have studied. With this, I am going to sign off from today's lecture. That was all about erythropoiesis. It's a small chapter, but a very important one. Have a good day. Allah Hafiz.